Hello, everybody, and welcome back to another wonderful episode of Boston DevOps Bill. My name is Bill Oliver, and today what we're going to do is we're going to begin adding the dis to our provisioning script. So in the last couple of sessions, we've actually started defining our dis provisioning script, and in the script, what we had was we had a series of parameters which represented really a structure like you would see in C or Pascal or Go or any of those languages. And we defined those parameters so that we could pass in what type of drive we wanted to create. And we had just a regular drive with a file system. We could create a thin provisioned volume, or we could just create a regular logical volume. So today what we're going to do is we're going to define each one of these. And our regular drive will have a single partition, and we'll create a file system on it. So very basic, very, straightforward. Our next drive that we can create will be a logical volume. And with the logical volume, what we'll do is we'll take the entire disk, we will convert it into a physical disk, and then we'll use our parameters to check to see what the name of the group is. And if the group doesn't exist, we'll create the group, and then we'll create the logical volume on top of that group. And then, we'll actually create a file system on top of there. If the group does exist, what we'll do is we'll just add the drive to the group. Since that volume will not be mounted, what we're going to do is we're just going to rely on the file system to update itself on the net as it's being booted. Okay, so we won't have to worry about that. For our thin provision, what we're going to do is we're going to pretty much follow the same sequence of events as we did for the logical volume, but we're going to add a new volume to that, which will be the metadata volume. And then we'll combine those two together, put a file system on top of it, and enable monitoring, as well as giving it a profile that says how we want these drives to grow. Now, one of the big things about running a thin provision volume is that the last thing you ever want to do is have your metadata volume being too small. So I'll show you how to calculate that. And for our testing, as of this point, we're just going to pick an arbitrary percentage to allocate to it initially that will really allow us to create the meta drive at a significant size that we can do other things inside of the volume. Because right now, when we create it, we're only using a 50 megabyte drive. So that's really very small. So we can't really say take 1% of the drive, because that's not enough to store all the metadata in. So what we're going to do is we're going to, I'm picking arbitrary size just for testing. And I'll give you some pointers as to what we want to do, in a production mode. Okay. So we got a lot to cover. It's going to be a fun show. It's going to be probably, in that longer period of time as usual, but we're going to try to get through all three. If not, we're probably definitely going to do the drive and the logical volume, and I'll save if time is getting tight, I'll save the thin provisioning. That way, we can go over it a little bit more extensively for the next episode. All right. So this is what we're going to do today. We're going to pound some keys, and I mean pound. So get ready, get set, and let's go do it. Okay, everybody, welcome back. And let's go ahead and stop pounding some keys. I'm inside my Vagrant build prod machine inside of the storage directory, and this is where we defined our VM addDis.shell script. And let's go ahead and jump into it. A VM script really takes in three parameters that represents a complete description of a disk for us. So it's sort of like a structure we're passing in. We take as the first parameter in our tuple, we take in the size of the disk, we take in the type of disk we want to create, and we take in a group, okay? And the group itself gives us the ability to create a volume underneath it. And we do this for the thin drive and the logical volume. For our standard drive, we take in the group name of none because there is no group, okay? But we want to insist that if you put the word drive in there, that we do have a criteria for that, and that criteria is that it must be none. So our criteria for the thin and for our group, our actual drives, it has to be thin, logical volume, or drive. And of course, we take in any size. And so scrolling down, what we have is we have the three functions which we left off on, which was fun drive, thin drive, and logical volume. And these are the actual drives that we're going to use to, these are the actual routines that we're going to use to define the drives. So coming down, we first take in all of our arguments, we go through, we process them, we make sure that we have a number for the first parameter of our tuple. We make sure that our second parameter inside of our tuple is either drive, thin, or logical volume. And of course, our last one, if the type of drive selection is a drive, then we make sure that it has none. Otherwise, we just record the group. After which we come down and we go through a series of checks here. And what we're checking for is we collect all the disks from dev that pertain to our hard disk. And we filter out anything from a mapper, okay? And we go through and we collect the dev name and the size of that device, okay? And from there, we compare inside of our little statement here whether or not that drive is in use. In fact, one of the things which I noticed was we do that for the block partition, but we don't do it. We do it for the block, but not the partition. So I'm just going to add a really quick check here. And I'm going to use user bin ls to identify whether or not we have any partitions hanging off of our block devices. And to do that, I'm simply going to take the entry, and which is the 0 entry of our array, which contains the actual device name. And I'm going to check to see if that device name has a partition. And I know partitions start at 1, but I'm just going to catch the 0 through 9 in case we have a 10. Okay, so I'm going to then redirect any errors which may emanate from this. In other words, if we don't match anything, it's going to say, hey, can't find this, and we really don't care about that. So what I'm doing now is going to just say no partition. And if it's equal to no partition, then we know that this particular block device does not have any partitions. If it's not equal to no partition, then we know that it has at least one because it matched our ls query. After that, we come down, we actually try to mount that block device, and if we find that we can mount the block device, that means that it has some sort of a file system on it. So we want to definitely ignore that because that means that disk is in use. It's not a perfect criteria, but I think it's one that we can live with for right now. Okay, coming down, we then go through a series, we go through a loop through each one of the three tuples, looking for our drive and calling the appropriate function for that drive. And that leads us, and that's where we left off. So we have, left off with pretty much just identifying that our routine to call, if it's a drive, if it's a thin, or if it's an LV, the corresponding functions. So one of the things which we're going to do is we're going to define this now. So I'm going to begin this by right above the for loop. I'm going to change our field separator to space. And the reason why I'm changing that to space is because we need to issue a series of commands to fdisk, which we're going to use. But before we do that, I want to add a little bit more constants that we're going to use this time. And the constants which we're going to use are basically, one second, I got it over here, and I figured I'd just copy it in so that my typing would not slow us down as much. And here we go. See, I'm in the need for speed here, so I'm trying to go as quickly as I can, and I'm rambling on, so bear with me. So in any case, you want to pause this video and copy in these particular constants, because what they are, these are the commands that we're going to use to manipulate our thin drives in our logical volumes. And we also have our fdisk down here, which we're going to need to define partitions for our standalone drive. We have a makefs, which we'll use to put a file system on top of these logical or the physical drives and the logical and the regular drive. And in the file system which we're going to use, we're going to use the default XFS system or file system, which is actually a journaling system. It's rather new, but I'm kind of surprised that Red Hat and CentOS has jumped on it so quickly. However, I did a little testing with it. It seemed to work okay. I didn't run into too many major problems. But then again, I didn't do extensive testing either. So I'm somewhat new with the XFS system or file system, but we're going to use it anyway. Okay. So one of the things which we want to do is begin, and we're going to begin by building out our fun drive, our function for the drive. And to begin with, what I'm going to do is I'm going to define a variable, and that variable is going to be called fdisk cmd. And the fdisk cmd is actually an array that, or actually a string of values which are going to direct fdisk to create to actually implement their menu system or activate their menu system to format the actual drive. So I'm copying a set of comments here, and it's going to kind of explain what we're doing, okay, with this string. And let me jump out real quick. And if we do a sudo and then echo in the letter M and pipe that into fdisk, and I'm just going to give it an arbitrary drive. It's not going to do anything with it. But if you know, whoops, wait a second, what did I do here? Oh, not paying attention again. Okay, so what happened was I echoed in the command M for help into the fdisk utility, and what it did was it actually displayed the command, and that's exactly what we want to do. We want to be able to specify that our commands that we want to use in order to format the drive can be executed, in a non-interactive fashion. So that's what this list is about. This list is about the commands that we're going to use. So to begin with, we have X, which is the entering of the extra function menu. And then we're going to use C to define our cylinders, and V. And when we simply enter a blank line, that's simply accepting the default. And that's the same with V for verify, R, N, P1. And NP1 basically says we're going to add a partition. It's going to be a primary partition, and we're going to take the first value of that partition. So any drive which we pass into this, we expect is just going to be an empty drive, and we're just going to whack it. So now that we have our fdisk commands defined, let's go up to our drive function, and let's define how we're going to actually execute this. And to begin with, what we have is we're just going to put a little comment here and say format the drive as a Linux drive. Okay, and let's say echo, and our command, which is $fdisk commands. And we're going to pipe that into fdisk. We're going to use the device which we pass into this function, which is distdev. And then we're going to check the status of this. And if the status is good, and good means equal to 0, yes, the lights are going to, flash, and we're going to be really happy. There'll be people dancing in the streets, all sorts of wonderful, happy stuff. Okay. In fact, we're even going to help them by echoing the status of success. So as this script runs, it's going to inform us what it's doing and what the status of each command is, so that we have a way to go back and debug it if something fails, or the best we can. without really getting our hands too dirty. But when it comes to debugging things, we're going to get our hands dirty. So in any case, if it fails, I want to identify it with a band of asterisks just to call our attention as it scrolls across the screen, and we suddenly find ourselves stopping. Status. And if it fails, then we're going to return a status of failed. And then we're going to call our fatal routine. And we're going to tell us that we're taking action. And the action that we're taking is we're going to abort. Aborting. Yeah. How about aborting? Okay, so that ended that. Now, at this point, we have our drive fully partitioned. So what we want to do now is we want to apply a file system on top of that. And this is going to be a common thing. And, so what I think we're going to do is we're going to go ahead and take a little diversion here. And let's go ahead and define a routine that we can use, which is kind of cool. And I call that routine the check results. Okay. And check result is a very simple function that allows us to let's see, check result. And what that allows us to do is simply execute a command and get the status for that command. And that's all it does, okay? And if the command fails, it dies. Period, the end, okay? Ash to ashes, dust to dust. If it would have worked, it would have been with us. That type of deal. Okay, so let's go ahead and we're going to put a little block of pound so that we can actually identify, what actually is scrolling across our screen. And I keep saying scrolling across our screen because, this is going to be called inside of our Vagrant script, and it's going to have to execute these wonderful commands. And to do that, what we're going to do is we're going to prime the pump, so to speak. And if you've never had to do this before, it's fairly common to, abstract an execution block simply to clean up the logic so that you're not, overwhelmed by so many if statements that, basically don't really need to be, that really don't add anything to the logic other than checking the results of something. And when we check the results of something, we really just want to, say, hey, give us a standard way to say the status and success. Okay. And we can do that again and say if it failed, put our wonderful stars up there so that we can see that we actually went in. This command will fail. So you'll see the actual pound, the description, and then you'll hit the error message. So status :failed. And I should just copy this from below. And we can do fatal, and it will be action : aborting. And we got a fee, and we'll close it off really quick, and I'll go back and clean up some of these quotes which I screwed up on. And that looks about right. Is that right? Check result. Echo command S. Okay. That looks about right to me. So if we got the actual variable names correct, and I'm sure I did, then we're all set. So let's go ahead and see how this is used. Okay, so to begin with, it's going to help us document our script, because now we can give it a description, and the description here will be create file system on drive distdev. The command to do that with will be makefs. Oops. Forgot the. And the command args. Okay, and that will be an array which we're going to pass into it, which, you know, is just going to have for us the -f that says force the file system on it, even if there's another one, which is pretty dangerous, but we're in testing right now. So this is one of the notes which we want to make to ourselves to review this. Okay, and dev. And we're going to have to supply a 1 here because of the fact that our drive, block drive, have a partition that we defined on it. So we're going to add a couple comments here, and I'm going to put a to-do, and we'll search out for to-dos later to find out what we need to go back and address. And I'm going to say added dangerous flag -f to overwrite possible existing file system signature. This also is going to have the effect of actually wiping out whatever contents are on there. So this is why I put the to-do statement in there, because after we're done with this, we can look at this, you know, after everything is working, we got everything debugged, and determine whether or not we want to keep this around or, in fact, get rid of it. And the second one, which I want to say, is must add 1 to the disk to represent partition 1. Okay, so that's what this one is for right here. Okay, that's why it's there. Otherwise, we'd run into a bit of trouble because we wouldn't be referring to the actual partition, we'd be referring to the block device. So why don't we take see if we got this working. Okay, so sudo /VM, and we had defined 50 megabyte disks before, and let's go drive. Oh, you know what? Those might still be in use. So why don't we do this? Why don't we remove any file system which we have on there. So let's do a sudo pvs minus a. And it doesn't look like I have anything defined, but just in case you do, let's do the following. For I in, let's call it SDB, SDC, SDD, SDE. Okay, these are all of our disks which we have. So because we're probably going to do this again, we're just going to say do, and we'll do a sudo, let me see, wipe fs minus a, and let's give it /dev/$i. And then let's really make sure that the disk is clear by simply doing a dd. And what we can do is we can define infile of dev0. And what this is going to do is this is going to write zeros to the disk. And our out file for that will be our dev $i. And we're going to give it a block size of 512 with a count equal to 1. And basically what that's going to do is for the first 512 bytes, it's going to write it inside of our device. And the first 512 bytes is our partition table. So just in case wipefs didn't do a good enough job, we'll come through and we'll get this all done with the DD. So just a little insurance. So if your drives weren't zeroed out before, they are now. Okay. So let's go ahead and run our VM add script. And we're going to give it 50 because these drives are 50 megabytes long. I'm going to give it the drive, and I'm going to say none. And we got an error expected then on line 53. Oh boy. Yep. That would be a problem. That was not supposed to be a then, that was an else. That's one of those I was talking and typing and thinking all at the same time. Yes, it was dangerous, and I just proved it. Okay, so what do we have now? Do you really want to quit? Okay, this looks like we have something missing on line 51. Let me see. Damn. Am I doing good on this one? Okay. I think that should resolve that. Okay. fdisk commands. fdisk commands. Really? Okay. All right. 3 times the charm. Okay, look at that. Okay, so basically what we have is it executed, it sent that strings through. We created the number of cylinders, taking the default. We actually listed out our verification. We created a new partition. We said that it was a primary partition and that we wanted one inside of there. So the first sector, or the first partition, which we defined, which was the default. And then we come right on down, and it looks like we changed our partition from Linux to Linux, which is good. And then we created the file system on top of it. Perfect. So let's see if we can do it again. Okay. So now we did dev SDC, dev DD, and dev DE. That doesn't look good, to tell you the truth. So let's do a /dev/sd star. Oh, and it does look good. Okay. Oh, there we go. I was looking at the wrong value. I was looking for the SD1, and it looks like we are defining that one partition. It is working perfectly. Okay, so let's go ahead and clean up. Come back here, and we'll do a full zippy there. And what do we have here? Let's do a sudo pvs -a. In fact, we clean them all up. Okay, so that's great. So now what we want to do is since we got the drive working, let's go ahead and define our logical file system routine. All right, so let's jump back into our script here. And let's go down to logical volume. And let's start defining the logical volume. And the first thing which we're going to do for logical volume is we're going to create the physical drive. Okay, so we're going to create a physical drive, which basically all this does is it preps the drive so that we can add it to the volume group. So for that, we're going to say it's disk dev. Okay. And the command which we're going to use is we're going to use $PV create. And PV create takes an argument of the arg. Maybe I shouldn't talk and type at the same time. Disk dev. I keep saying that, don't I? Okay, and we're going to do a check result. And as you can see, it's a fairly efficient way of describing a sequence of commands without muddying up the logic. We can see very clearly that, we're creating a physical drive. It's called disk dev, and we're calling the command pv create, and we're passing it a single arg, which is our disk arg, and we're calling check result. If we don't come back, we got an issue. Okay, as we already seen. So the next thing which we want to do is we want to create the logical group. And this is kind of self-documenting code, which is very important. So anybody who comes through here afterwards can pretty much, determine what we're doing without really having to know too much. Okay, so create volume group. And the command which we're going to use is $VG create. And there is a pattern to these commands. PV is physical, anything to do with the physical drive. VG is the volume group, anything to do with that. And LV is a logical volume. So all of our commands are pretty much the same except for what we want to work on, be it the physical drive, the volume level, or the group level. So if I do that, then I'm going to do a command and arg. And you guessed it, all we're going to do is we're going to give it the group to create. And then we're going to do a check result. And our check result should be good. Okay. I don't see any typos so far, which is kind of a first. Is that an equal sign? That is an equal sign. Okay, so I'm good. Okay, great. So the next thing which we're going to do is we're going to create that physical volume. So cmd des equal create logical volume. And to do that, we're going to use the command $LV create. And the command arg. Okay. And our command arg is going to have to specify how much space we want to allocate from the group into our logical volume. In other words, we can actually hold back, a little bit, just in case, because you give people too much space, they're going to fill it immediately, and then they're going to cry they need more space. We may not have extra disks. So in creating the volume, you want to hold back some of it. For us, we're just going to give it the 100%. Okay. So, and I'm going to do that through the -L command. And I'm going to say 100% free. So give it the entire disk. Okay. And then we're going to name our disk using our group, which is dsk grp. And we're going to attach the name volume. And the reason why this is going to work for us is because if we have the same group coming into our tuple, we're going to say, hey, we just want to take that whole disk and extend the volume group on it, and then extend the logical volume on top of that, okay? So we'll never have the case where we'll have a duplicate volume name, okay? But in looking at the system, I also want to make sure that it contains the group name inside the volume, simply to track the where it's actually created, okay? In fact, I believe the group name is also appended too, so it's kind of redundant, but we'll live with it, okay? So basically, that's our group that we're going, that's the name of the volume that we're going to create. This is our volume name. And this right here is where we're going to put it. We're going to put it inside of this group, which we have. And then we're going to call check results. Okay, and that should end that. Okay, now so at this point, we created a physical drive, we put it inside of a volume group, and then with that volume group, we created an allocated space to a volume, to a logical volume, and that's all we're doing here. So the only thing we really need to do is we need to format the volume. We need to put a file system on top of it. And to do that, it's a very simple command, okay? And the command which we're going to do is we're going to make a file system, okay? Create file system on top of logical volume. Okay, and to do that, we're going to use our wonderful makefs command. And again, we have that dangerous flag that we're going to throw to it. And I keep saying it's dangerous because, if for some reason we have a bad check, okay? In other words, I think this is the second video where we defined it the first time, I tweaked it the next time, and here I'm tweaking it again as to what is an empty volume, okay? Throwing a -f on here is kind of dangerous because it's saying that we're relying on these checks to be 100% right, okay? And in fact, inside of our closed system, it is correct. But if this is in a production system, then that in itself may not be true. So that's why I'm calling this a very, very dangerous flag. Okay, and I'm going to put a to-do here. And that to-do is the same to-do which we had before. And I'm probably just going to copy that text for consistency. Okay, added dangerous flag to flag -f to overwrite possible existing file system signature. Okay. And bingo. Okay. That's not where I wanted to put that. You should have told me. There we go. Okay, so now that we have that out of the way, we're going to address the actual system by disk group. Okay, so it's dev disk group $disk group again, and the word volume and a parentheses. And what that does is that describes our volume which we're creating. Okay, so let's do a check result. And voila, we are done. Okay. But we have something which, if we want to check to see if this group exists, which we really do, then we're going to have to add a couple extra texts. And the reason why I say this is because we just described the happy path, okay? The group didn't exist. The volume didn't exist. So we just went ahead and created, the actual physical drive. We created the volume group. We added the drive to the volume group. And then what we did was create a regular volume and put a file system on top of it. Okay, so in fact, what I forgot here was to add the actual disk. Because when you create a volume group, you specify the name and you add a disk. I knew something didn't look right. So basically, now what we want to do is, since we have the happy path defined, what we want to do is we want to go ahead and say, okay, well, what happens if I call this again with the same name? That's not the happy path. That is, that's the extras that we have, okay? So in order to do that, what we're going to do is we're simply going to do a simple test. So if this is not empty, okay, and this being the $LVS command, because we're going to have to check to see if the group exists. So we're going to do this by saying no headings, okay, and we're going to give it the -o command. And what we're going to get is we're going to get the volume group name. Okay, this is a way in which we can query the logical volume system to find out what groups are actually defined. So we're going to grab all the groups. We're going to grab them without inherent heading, which means that they're basically just going to list out the group. Okay, and we're going to pipe that through unique. And then we're going to do a grep -i of $disk group. And if we come back with a match, okay, it's not going to be null. So if it's defined, that means that we definitely don't want to come in here into the happy path of creating the disk. Okay, what we want to do is we want to go to the nets one, okay, or we want to go into the else clause. Okay, so the only way we come in here then is if we don't get a return hit. So we're going to put a not there. We're going to push all of this over. And then what we're going to do is we're going to define the happy case to extend the logical volume. And you can imagine that extending the logical volume is going to be the same exact way that we do it for a thin drive as our regular volume here. So what we're going to do is we're going to create an extend function. Okay, so right here, I'm just going to say extend the group with the physical drive. With the new physical drive. Okay. And why don't we call this, in the spirit of what we have before, fun extension. Okay, and we know that we're going to need a couple of things. Here we're going to need the disk drive, and we're going to need the group name, of course. So that's DSK group. And of course, we're going to need the volume name. Okay. Or what we gave the volume identifier as, which is the VOL. And then we are done with that. So let's go ahead and take a quick look now. So if it's not defined, in other words, n is actually blank. So if this returns blank, then we're going to come into here, and what this is, we're going to strip away the header. We're simply going to search for the group name. We're going to, if we get a list, we're going to pipe it into unique so that we get them unique. And then we're simply going to check to see if we got we have the entry inside of there, in which case, if we do have the group inside there, we actually locate it, then we're going to jump down to the to the else statement, and we're going to add it as an extension. If it's not, then we're simply going to add it then we're going to create the volume, and we're going to put a file system on top of that. Okay, so we have our drive, we have our group, we have our volume, and we have our file system. So let's come up here and create the utility function. Come down here. Okay, and we'll say fun ext. And what this is going to do is, all this is going to do is extend our drive. So we're going to say that ext dev equals $disdev and ext. And I do not have to do this, but I'm doing so for clarity. And the reason being is it's when you read a really large script, it's difficult to actually identify where variables are coming from at times. And, you know, you have to really, you know, focus on what's going on, which is a normal case, but it, you know, just becomes a bit difficult in that, oh crap, that I'm talking and typing at the same time, that knowing that that parameter which is coming in comes in from a specified source and it means something inside the function, so that you're not using the same variables all around. You can actually just, you know, focus in and say, oh, this is it, and definitively know that this function is using the values that was passed in. You know, in case you miss it, you know, it's very straightforward. So let's go ahead and define what's going to happen when we pass these values in, okay, and when we extend a file system. So to begin with, we're going to have to create a physical volume, which we know how that works, right? We simply says des, and we say we're going to create a new physical volume, and we're going to give a command of $pv create, and we're going to say command arg gets $. We're going to define the array of $ext dev. Okay. And of course, we're going to call our check result. Okay, now let's come down here. Oops, I can't do that. Got to do it this way. Just to make sure that I didn't whack anything. What we're going to do is we're just going to grab the group and yeah, that really wasn't worth it. Yeah, no. I was going to do that, but yeah, no. Okay. I'll do it the old-fashioned way. I'll make it up as I go. Okay, so what we're going to do is we're going to extend the logical, we're going to extend logical group by, or actually add the physical volume to the group. Okay, and to do that, we're going to use the CMD volume group extend command. Yeah, no. VG, thank you. And that's VG extend. Okay, and we have the command arg equal to $disk grp and $disk dev. And there we go. Now, let's go ahead and check results. Now, what we actually did was we added this disk here, which should be ext. I'm getting so used to calling it the other one. Okay, so we just added the physical volume to the group. So that gave us more space inside of there, but we need to know now how to extend it. How big is that disk? And for that, we're going to query the system again. Okay. And we're going to say now determine how big, how much we can extend the group. We can extend the volume, the logical volume by. Okay. So we need this parameter. We need to know the number of extents to, increase the logical volume. Okay. So in order to do that, we're going to simply say echo, and then we're going to, give a little space, and we're going to say get the free extents from the added volume, added physical disk. Okay, and to do that, we're simply going to grab the extents by, and we're going to put it in an array because there may be more than one. Yeah, so we're going to grab the extents, and we're going to say $VGS, which is a way in which we can query the groups now, very similar to what we did with LVS. And we're going to say ext group, and we're going to look for the volume group free count, and we don't want any headings. Okay, and what that's going to give us, that's going to give us a number. But unfortunately, sometimes if the format changes, it'll add white space or something like that. So we just want to strip that white space away. So I'm going to call it free extents. Okay. And I'm going to give it the extents. Did I spell that right? Yeah, I did. Okay, good. So the extent sub 0, and I'm going to strip off any spaces. Okay. And that, my friend, it gives us a real number which we can then feed into our next command. And I'm just going to say free extents available is $free extents. Now notice how I'm putting in brackets just in case there is some bizarre white space that gets through, or some other character, or maybe we grab the wrong value or something like that. Okay, so let's go ahead, let's put that there, and let's go ahead and take a quick look at this for a second. Okay, that looks right. And I'm just going to put a little echo there. And now we're going to extend the logical volume by the free extents. So, as I said before, we're allocating 100% to this. Okay, so let's do a cmd des. And we're going to say extending logical volume by free extents. And we have CMD, and to do that, we're going to use LV extend. And we're going to pass it the arguments of -L. And here we're going to say a plus. And that plus represents adding, whereas a minus would represent reducing. Okay, so just keep that in mind. Okay, free extents. And we want to give it the actual device, which is ext group /$ ext group and $ext name. And what that gives us, the proper name for our volume, okay, because this is our volume name, the group appended by the volume ID, which we gave it, okay. And of course, we want to do our normal check results. Check result, okay. And that should do it. That should extend our drive. So let's take a real quick look at this again. That looks halfway decent, but it always does to me. Let me see. Okay. LV extend. Okay. Then we defined down here. That looks correct. Disdev. Okay, I think, therefore, I am. That is correct. Okay, one last check down here. Okay, we're passing it the dev, the group, and the volume. And up here we are receiving the dev, the group, and the volume. Okay, so that looks good also. All right, so let's give it a whirl. And what do we have? Sudo pvs -a. Looks like everything is cleared and ready to go. So let's come back here. And instead of saying drive, let's say logical volume And let's give it something logical, right? How about Spock? Okay, that seems logical. Ooh, and we got a success on our first run. Okay, so running this for the first time, we added the SDB drive or block device as a physical volume. We then created the group Spock. And then after that, we created the logical volume. We're wiping the XSF signature on dev Spock vol. As I said before, that, it'll come back and you'll say, hey, this existed. But, and that's why we gave that dangerous flag. And in fact, it created the file system fine. So what happens if we do it again? So that was the happy path. And if we do it again, we got another success. And the success here is that it added the extents. And we can, in fact, we can see that right here, that we created the physical volume, SDC. We added it to the group. It was the group Spock was successfully extended. Of course, it's just logical, right? And then we got the free extents added to the physical disk, and the free extents available was 12. Okay, and we come down here and we changed from 48 megabytes extended to 96. Okay, which was 24 extents. So that looked perfectly good. Okay, so why don't we come back here? Okay, in fact, why don't we do this? Let's add a regular drive. See what did that take? Okay, that came in at SDD. So far we're good. Okay, we got an we have our SDB. We then created another one, or we added one actually, and that was SDC. And then we just created a new one using our drive, okay, which was the regular drive here statement, and that put it on SDD, okay. So if we do an ls of /dev /sd star, okay, we do have, in fact, an SDB and SDC, okay, and SDD1, okay. So let's see what our sudo pvs -a says. It says that we have used for our logical, we're using SDB and SDC for our logical group Spock volume, okay. SDD doesn't have anything other than SDD1, okay, so that parameter is in use. So that means we can do one more thing, and let's go ahead and extend it one more time, okay. Ooh, and it did. That worked, okay. So we can successfully do that, but now, what happens if we add another one to Spock? Oh, we don't get there. What about another drive? We don't get there. So we did some rudimentary testing. We got 2 of them done, okay, which was the drive, and we got the logical volume. So the next one which we're going to do is we're going to do the thin provision drive, which is pretty good because, the thin provision is a handful. Okay, because I want to talk to you about, what happens if your metadata pool is too small, which is going to cause all sorts of, ugly problems if you add too much or whatever. And we also want to talk about how to calculate out that size of the meta volume has to be. And then we're going to, go in and define how all of this is defined inside of a thin provision drive. So in the next episode, we're going to do all about thin provisioning because there's a lot there, as well as to go in and actually look at some of these commands, which I kind of just glossed over in order to get these, defined. So I think we'll have enough time next time to do both a lot of testing as well as a lot of investigation of commands, like the LVS command, the PVS command, the VGS command. And then there's displays like the LV display, the PV display, and the VG display, and then there's the scan. So there's all sorts of neat commands surrounding this. We haven't even talked about some of the reasons why we're doing things of this nature, but we'll get into that next time. Okay, so thank you very much for tuning in. I hope you've had a lot of fun, just like I did, and may you learn how to type and talk better than me at the same time. Okay, so that's the show, and the world will never end if you hit that little subscribe button down below, and don't forget the little bell so that you know when the next time I release my episode here, and it's coming up within the next couple of weeks. Okay, I know you don't want to miss that. This could be the opportunity for you for a lifetime to see this upcoming episode. The drama, the suspense, the intrigue. You definitely want to see it. Okay, so don't forget, hit that button down at the bottom. Subscribe. You'll feel much better. Sun will open. You'll just be fantastic. You'll just have a great day. So, thank you very much. This is Boston DevOps Bill Oliver, and I'm looking to see you next time. And I'm looking to see that subscribe, rate go up. Okay, so don't forget, hit the subscribe button. Thanks a lot. Bye-bye.